Hello everyone, welcome back to my channel. Now I'm going to share with you another small project. It's called weather forecasting. So I should not have started this project because actually when I saw the Wikipedia page about the weather forecasting, it is a very complicated subject and was including lots of algorithms, a lot of history and algorithms, and different government institutions are actually conducting the weather forecasting on a daily basis. Okay, so I just simplify the weather forecast to show you how to implement three models. Of course, again, I interact with large language model to refine my code to make them robust. Okay, so at the beginning, I have a small description of the three models. I have ARIMA model, VAR model, and the long short-term memory models. So basically, the long short-term memory model is more prone to the deep learning, machine learning parts. It's more complicated, right? For the VAR model, is like you have not a univariate. You have multiple variables simultaneously to influence results. Okay, so it's preferable when you want to model the time series where multiple variables are moving together. ARIMA model is univariate, means that there is only one variable you are concerned with. Okay, so let's see how these models perform. Again, if you want to dive deeper to the theory background, I really recommend you to look at the Wikipedia, like official books, okay, to get more robust descriptions. Below, let's go to see the code. Okay, so basically, I have the first version of ARIMA model. So, okay, I use the package. The most important package is Meteostat. Okay, this package actually can get the weather information. Okay, basic weather information for me to do the analysis. Okay, I'm going to focus on several variables you are going to see later. So basically, first of all, I need to get the weather. So I have this function. I choose New York as the analysis start. I just choose this location. And I have a time period from 2020. Okay, and also I get the data and also print the data head. So basically, I'm going to have the temperature average, blah blah blah, 1, 2, 3, 4, 4 variables. Okay, as you can see here. Then I preprocess. Okay, preprocess the data. So it's there is one of the experience that I will share with you for any numerical data. It is better to standardize. Actually, to make sure they are on the same range, it will be better for you to analyze. So if, for example, if you have one variable is 1 to 1,000, another variable is 1 to 2, the range actually will impact the analytical result very significantly. So this min max scalar, okay, this kind of transformation is useful. Okay, you have many other transformation methods you can try. Then I use 80% of the data as training, 20% as testing. And also we can also print the shape of the train and test data. And now we're in the modeling part. Okay, so basically the most important part is first of all, we need to understand how to evaluate the model. Okay, previously you already understand how the model works, but how good is the model, I think, is the most important part. So I need to I just chose two of the metrics to evaluate the model. Of course, you can also add other metrics in your case. Then we do the forecasting utilizing this model. Okay, so basically at first, the features, or I say the parameters of the ARIMA or P, D, Q, three parameters are preset. Okay, just for simplicity. Then we do the prediction and transform the prediction to original scale. Okay, I think this part is out of my expectation. So ChatGPT really did a good job to mention this part because we need to see the original format of the data. It's better for us to understand. And you see this is a model result. Okay. Yeah. So after running this code, I see no visual. Okay, I cannot do variations. And here I try to fine tune this model. Okay, so Basically, for the different variation of the model, I want to see the results and add this widget so I can choose a different parameter and train the model. It is strongly suggested because recent days I find the Colab widgets documentation is super useful. It will make your interface very interactive. You can try the different parameters, not only here. In the future, I'm going to tell you how to use it in the artificial neural network. Okay, when you try this, each time you are like doing experiment, it will give you better sense. Okay, so like in this case, I change one parameter, it will give me one result, right? So in your network, when I change the layers of the neural network, I change the neuron numbers, I see different results. And I can even say I can see how much training time do I need, okay, computational cost and accuracy of the algorithm. I can find the balance. Okay, for small to medium data sets, I think you can do this kind of test to choose. If you want to scale up, it is another story. You may need to use different tools to handle large data sets. But in the first experimental part, I think adding some of the widgets will be very useful for you to test and see the results. Okay, so the first version, okay, I understand there is ARIMA model, right? And ARIMA model actually does some of the job and also provide preliminary information. So let's try to improve, okay? So this part, collection processing, I just leave it here, okay? Then I still utilize the widgets and try to predict. Okay, in this version, okay, I can see different variations, right? Each time when I run this model, I change a parameter. It gives me round 1, round 2, round 3. And I also, beside, I can see, except I can see this matrix comparison, I can also see the actual and the predicted value comparison, okay? As you can see, it is not very good from the direct visual examination because you can see the predicted value and the actual value are quite deviated from each other, different from each other. So at this step, we know that the widgets and different visualization can work together very well, right? We can keep moving on. So in the third version of our ARIMA model, okay, let's see here, third version, of course, we install dependencies, and then we go to the main part of the code. Yeah, for the main part of the code, actually the key difference here is to make this kind of layout and also mark the dates. You know, whenever you handle the dataset, you need to pay close attention to how you split the train and test data and how you make the prediction. Okay, so for example, I choose this period of the data to train the model, but eventually I want to predict, for example, my forecast window, forecast days is 7 days. Okay, originally. So what my original intention is to use all the historical model to train the model, historical data to train the model and predict the last 7 days of the data set. So you need to be careful to change the parameter to make sure that your code does this job. So sometimes when you split like the train and test data, there is a tricky balance. How do you separate the train and test data, right? I still separate that 20% train and 20% test because my forecasting range is inside of the training data set. Yeah, inside of the dataset, I do the training and testing. So it is not 100% robust. You can also have different setup, like you have train, validation, and the test. So you can leave the last 7 days data not seen in the dataset and to model, to train the model. Okay, that is another approach. But I personally speaking, I really doubt it will make much difference, okay, because the 7 days data is very limited, okay, but you can try. Then I can also see in each run, I can see this matrix comparison. Of course, I want the error terms as small as possible. So let's see if I change the parameter here, okay, and I see there is an increase of error. Of course, my choice is a bad choice. Then I run another one. and I can see my error keeps going up. So there must be something wrong. And also pay attention to some of the errors mentioned by the package. It will not stop your program, but it will actually give you some indication to how to improve your model, okay, or algorithm. So you can see the next one here, okay. So the error actually dropped a lot. I think is good from compared to model 3. Okay, so this just shows you that if you want to experiment and see some change of the graphical representation, I think it's very good for you to understand the different parameter tuning and give you a very direct sense. Okay, not always just look at the pure number or pure description. Okay, so far so good. So now we look at another two models. One is called the VAR model. Okay, for the detailed code, you can check later. Of course, the main part is about training the model, forecast with VAR. It's very simple, right? Because most of the heavy work is already done here inside of the package. Okay, so let's see. In the end, we still have the widgets to change the parameter, change the sample data range, okay, and to see different results. Okay, it looks pretty good. Okay, for each time you can see if the model predicts these days data, how does it perform? Okay, then you add another run, another run, another run. Okay, so this is a good way for you to test the parameter tuning for any model. I really recommend you to add widgets to your Colab notebook or any of the model you want to learn, you want to try. It is very useful. Okay, so basically the VAR model is different from the ARIMA model because it can handle the movements of different variables together. Okay, I give you a simple explanation here, not an official one, of course. And here let's see the long short-term memory. Long short-term memory actually involved is more computational intensive because it actually takes more time to train. You can see this one. This one is a long short-term memory model. If I remember correctly, this is from the package of TensorFlow. Okay, whenever we say TensorFlow, it means that we are going to the deep learning area. Okay, we can simply understand like that. Okay, so we have this big function to actually predict, okay, using a long short-term memory model. Okay, so for the detail, I think is similar to other deep learning model. You need to understand the input and the output shapes and the data, and you set different parameters inside of this function. And pay attention, one part is about the verbose. Okay, if you want to see the training process, either in here or the neural network, if you set as 1, you see a lot of training process. You set as 0, you see only results. Okay, so the other parts basically similar, and let's see. Okay, we still have the widgets, and you can see here is the progress bar. I think it's useful. Sometimes you want to know how much time you are going to wait. For the previous two models, ARIMA and VAR, you see it goes by very quickly. But for long short-term memory, it is very computational intensive, as I said, so you are going to see it moves slowly. This one is also customizable. If you change it, you are going to have the visual you want. Okay, so let's see. Similar as the previous one, whenever we change like the window size and the forecast steps, okay, we can see different results. Okay, so basically the forecast steps means that how many days forward do you want to look, or in our case, how many days of the last days you want to use a model to forecast. Okay, so here we have it. So as we can see, okay, although my choice of the training about the train validation test has some problem, right? Just for simplicity, I just separated to train and test and use this model to actually predict the last several days, okay, directly. So the eventual results, as you see, modeling or forecast 7 days of the weather stats is not so easy. Okay, as I said, weather forecasting is a very complicated subject, but at least we tried some algorithm, they are not working so good. So let's take a look at another way. As you can see, this is the data set I show here. Also, you can try directly with Colab default function to visualize the distribution of different data. Now let's see from another perspective. So since the widgets are very useful, we can just get the data, okay, weather data, and we just use a widget to display it. The reason I want to also recommend this way of visualizing data is that you see the weather, it has the seasonality issue, okay. It is one of the issues that we handle the time series data, either economic or other data. So every year you see there is a circle, right? For each month you have a direct trend, like from August to September, usually you have a drop of temperature, right? So it's like a common sense. And if you see the historical data, it will give you indication of how the weather will be like in the dates that you want to check. So this is another way to, I mean, for our personal use, personal test, if I want to understand the average temperature or the trend, I can just check the historical data without predicting. Okay, so in the future, I'm going to share with you another test I did. I used the more complicated models, and eventually I see that, okay, the best model fits the data, but it is very close to the historical data. So which means that although some of the models they can generalize some of the information, but if my feature space is not large enough, for example, if I do not consider all the factors impacting the weather, my model is useless. Like you see previous three models, right? So I can either use more complicated machine learning or deep learning models, or I just check the historical data. Okay, there is a famous saying that all the models essentially are wrong. Okay, so as you can see here, in the first instance, if I choose a variable, okay, I can see the several years trend, okay, on specific months, 1st January, February, and so on. Okay, this is the first version. As you can see, we can see some trend, but it's not very clear. So let's see how we can improve. So the second way, I can choose a variable. I can choose multiple years. First of all, it will show me the daily trend, okay, of a specific year of each month. Okay, so I can understand, for example, in this month, and compared with other months, how is the general trend of the weather. Okay, for example, in a specific month, you can see this is December. In December you have a very drastic temperature change compared to others. Okay, of course you can also choose other visualizations. This is just a preliminary version. And you can also see here the trend of 2024, for example, is similar to the previous one. The only issue is that 2024 we only have data until September. Then this one is the error bar chart that we can see the range, okay, the change of the range of the temperature. For example, this variable is temperature of each year, like the blue line is 2023, orange line is 2024, from which degree to which degrees, okay, and in which months the situation. This is March, okay. So in this way, you can say, okay, in 2024 we have the average or the general range of the temperature is larger than the previous year. Okay, and we also have a higher average temperature in some days. Okay, but you see, if you see March is this case, can we say April will be this case? No, not the case. As you can see, April maybe the range actually shortened. Okay, and also the highest temperature is lower than previous year. So it is very hard to forecast the weather data, but we can get some indication to support your decision making on daily life. Okay, so we also have the version 3. Okay, in version 3, I also added this choice of different city. So actually, if you took a look at the code, okay, so if you only utilize this variable, string variable, to get the coordinates, you either need to have an API to query a database, or you have a package that you can use to get you the coordinates, or you need to ask a large language model. So in this case, I directly ask GPT to provide me with these coordinates so I can choose from the drop-down menu. So it works fine. So I choose Rome, Italy. I can understand the weather trend and information of Rome, Italy. And I choose multiple years from 2022 to 2024. Okay, so this is information that I can get. Okay, first of all, from this project, I think to experiment some of the weather data, we can choose a free package. Right, this is the first point. Second point, we need to, when we try different models, we need to understand how it works. Okay, basic background of the models, how they handle the variables, and so on. And furthermore, please always check the different models. Okay, different models, different algorithm, which is situation most suitable to utilize such model, such algorithm, because if we have different data sets, different problem sets, okay, which kind of problem we want to solve, we need to choose the appropriate model. Okay, we need to know pros and cons. It's not only related to choosing model. Also, in the future, if you get deeper to machine learning, to deep learning, even to large language model, multi-modality model, we need to understand what is our objective. Okay, and if we are not just simulating or doing the regression or doing the training of the different model, we could go to another step to understand to choose a model to handle large data sets, or to fine-tune a model with our limited resources, or even, I mean, if you have a really enough resource, you can also develop your large language model, train your own model, right? So no matter it is about data science, it's about machine learning, it's about large language model training and development, we need to always evaluate the pros and cons of different approach and to choose the best one to reach to our target. That's all for this episode. I wish you like it. If you have any comment, feel free to leave a message to me. And if you like my videos, please subscribe and see you next time. Bye bye.